Hello dear students, how are you all? Today we'll be going to discuss class 10th physics chapter light, refraction of light. In the last videos we discussed about reflection of light and about the spherical mirrors and mirror formula. So what is refraction? Refraction is the bending of light or change in the direction of light when it travels from one medium to another. Refraction is used in building lenses, but the first thing which comes in our mind is what is the reason of refraction. And the reason is, as you can see in this diagram, air is one medium and water is another medium. And you can see this pencil appears to be broken because there is always change in the velocity of light when it goes from one medium to another. There is always change in the velocity of light. As you can see, in air we have as a rarer medium and water as a denser medium. You will understand this better when we will talk about refractive index, but whenever there is change in the medium, the velocity changes, which gives rise to the bending of light known as refraction. When we are talking about refraction, we consider a term which is known as refractive index. Refractive index is a pure number which specifies about the medium, whether it is rarer or denser, and refractive index is denoted as mu, or in some books it is denoted as n. What is refractive index? We write it as mu to 1. Now suppose you have air as one medium and water as another medium. The density of molecules in air is low and the density of molecules in water is high. So when you write the value of refractive index, we write it as it is a ratio of velocity of light in the first medium upon velocity of light in the second medium. Now in this case, this is medium 1 and this is medium 2. So we write this is the refractive index of second medium with respect to first. So you'll write mu to 1 as V1 by V2. Now in this case, we consider the velocity of air as c, so we write it as c by v. Now if you write mu 2, that means it is the ratio of velocity of light in medium 2 upon velocity of light in medium 1, which means this is the refractive index of first medium with respect to second medium. We generally write it as mu or n because if the first medium is air or vacuum, अगर पहला मीडियम एयर या वैक्यूम है और दूसरा मीडियम कोई भी डेंस मटेरियल है, लेट इट बी वाटर, लेट इट बी ग्लास, लेट इट बी डायमंड, so you always write it as mu as c by v. That is always the refractive index of second medium with respect to air or water. It has no units since this is the ratio of the velocity, so it is just a number, and diamond is having the maximum refractive index which is 2.4. That means it is the denser medium as compared to all the other mediums. In this diagram, now you can see a ray of light is traveling from air. Now air is a medium which is a rarer medium and glass is a medium which is a denser medium. You can see that the light is falling at an angle which is known as angle of incidence. We have drawn a normal also, but you can see अगर कोई medium ना होता तो ये ray सीधी जानी चाहिए थी, but because of this medium it has bent towards the normal. So you will keep in mind that whenever light travels from rarer to denser, it always bends towards the normal. That is, angle of incidence is greater than the angle of refraction in case of rarer to denser. Whereas, now in this diagram you can see the light is traveling from denser to rarer. Let it be water or glass, and let this medium be air. When the light travels from denser to rarer medium, you can see that the angle of incidence is less than the angle of refraction. यानी अगर लाइट डेंसर टू रेयर मीडियम में ट्रैवल करती है तो एंगल ऑफ इंसिडेंस जो है वो छोटा है, वेयर एज एंगल ऑफ रिफ्रैक्शन इज मोर, विच मीन्स इन दिस केस द लाइट bends away from the normal. Its reason can be understood with the help of Snell's law, which comes under the laws of refraction. So let us discuss laws of refraction. The first law of refraction is similar to law of refraction, that is, the incident ray, the normal, and refracted ray all lie in the same plane, as you can see in this diagram. Second law of refraction, which is also known as Snell's law, because this concept was given by a person named as Snell. Snell's law says, as you can see in this diagram, हमारे पास ये जो इंसिडेंट रे है, ये जो एंगल बना रही है नॉर्मल के साथ, दैट इज θ1, and the angle which the refracted ray is making with the normal is θ2. Let the refractive index of the first medium be μ1 and let the refractive index of the second medium be μ2. According to Snell's law, the product of the refractive index and the sine of the angle always remains constant in a medium, which means we can write it as μ1 into sine θ1 is equal to the product in the another medium, which is μ2 into sine θ2, or you can write it as sine θ1 upon sine θ2 as μ2 by μ1. Now sine θ1 is the angle of incidence, so we can write it as sine I. Sine θ2 is the angle of refraction, we can write it as R. μ2 is the refractive index of the denser medium and μ1 is the refractive index of the rarer medium, and in case of air or vacuum it is 1. So you always remember that this is the denser medium and this is the rarer medium. That means it can be written as sine I by sine R is always equal to mu denser upon mu rarer, and if rarer case is air, we'll write it as mu only. Now to understand why in case of rarer to denser the ray bends towards the normal, we'll use Snell's law, which says that it is sine I by sine R, which is equal to mu2 by mu1. Now in this case, mu1 is air, that is a rarer medium, so you'll simply write it as mu. But remember, mu is always the ratio of velocity of light, because this is the refractive index mu of the denser medium. So you'll write it as velocity of light in the rarer medium upon velocity of light in the denser medium. Now you can see the basic reason for refraction is change in the velocity of light, and as the light enters in a denser medium, the velocity decreases. So denser medium में velocity कम हो जाएगी. So in this case, if the velocity decreases, R will also decrease. So you will consider that R is always less than I whenever the ray travels from rarer to denser medium, because the velocity decreases in the denser medium. Similarly, you can understand that when the light is traveling from denser to rarer medium, why it bends away from the normal? Why R is greater than the angle of incidence? Again, you will use the Snell's law, sine I by sine R, which will be written as mu, which is equal to c by v. Now again in this case, if it is moving in the second medium, which is air, तो velocity क्या होगी, बढ़ जाएगी, because it is a rarer medium. If velocity increases, it simply means that the angle of refraction will also increase. So you'll remember that when the light travels from denser to rarer medium, it always bends away from the normal. Hope you understood. Another example of refraction of light, a person who observes a fish in the pond, or you can say the pond appears shallow as compared to its actual depth, because this medium is a rarer medium, this medium is a denser medium. If you draw a normal, then according to the laws of refraction, the light will be bending. The person observes the fish and the light will be bending towards the normal. But if you extend it, it appears as if the fish is not at the actual depth but at apparent depth. So it appears to be shallow as compared to the actual depth. Now let us discuss about refraction through a glass slab. You can perform this activity in your school lab. You can see this medium is air, this medium is glass, that means a denser medium, and this is again a rarer medium. And you can see with the help of a laser beam the path of the light being deviated. Now in this case you can draw a normal over here and again a normal over here, because this light is undergoing two refractions. Now you can see this is the angle of incidence and this is the angle of refraction. When the light travels from rarer to denser, it bends towards the normal. So in this case, the angle of refraction is lesser as compared to angle of incidence. Again this is angle of incidence and this is angle of refraction, and the light is traveling from denser to rarer, so angle of refraction is greater than the angle of incidence. Now let us understand this better. You can understand better with the help of this diagram. As you can see, that this medium, again incident ray is there and angle of refraction, and this is the angle of emergence. Now from this activity you can see that angle R is equal to R dash, because it's in the same medium, तो R जो होगा वो R dash के बराबर होगा. So angle of incidence is calculated and it is always equal to angle of emergence because of the two parallel phases. Prism के केस में ऐसा नहीं होता है. Angle of incident is always different from the angle of emergent, because in case of prism you have non-parallel phases. So you'll keep in mind that in case of a rectangular slab, angle of incidence is always equal to angle of emergence, because it undergoes the same amount of refraction on the two parallel phases. But you can see that अगर कोई मीडियम ना होता तो ये रे सीधी जानी चाहिए थी, but this ray has been deviated and this much is the lateral deviation. So the first conclusion is there is no angular deviation in case of a slab. Angular deviation नहीं है, whereas there is lateral displacement which can be measured by this activity. So there is some lateral displacement, as you can see in this diagram. Now next we are going to discuss spherical lenses, because they use the phenomena of refraction. Lenses, we have the lenses in our eyes as convex lens. Then we have lenses used in telescopes, used in microscopes, used in cameras, everywhere. So next we'll be going to discuss about the spherical lenses and the uses.